Folks, today I'm going to be talking a little bit more about categorical syllogisms, and in particular, I'm going to be moving us towards one of the methods for testing syllogisms for validity. And I hope I'm not scaring anyone when you hear this word. I'm going to be giving you the preliminary tools for applying the Venn diagram method for testing syllogisms for validity. Unlike what I will be calling the counterexample method, Venn diagramming, if done properly, is a foolproof method for determining whether or not a syllogism is valid or invalid. This won't be on a test, folks. But many of the foundational figures in the development of logic were also pioneers in what other discipline? Yeah, I heard it. Mathematics. John Venn was a logician as well as a mathematician. So unsurprisingly, if some of you may have had contact with this Venn diagram stuff, odds are it may have been in a math class, because logic typically is not taught in primary and secondary schools. You may have seen it in a math class, though. It was actually, this mathematical method was actually developed by a logician. And admittedly, we might use it in a slightly different way than you were shown it in a math class. Now, folks, the Venn diagramming method involves using interlocking circles. To do a full Venn diagram test, there will be 3 interlocking circles, like so. And unsurprisingly, each one of these circles will represent one of the 3 classes or categories that we're talking about. So you will be seeing 3 interlocking circles when we apply this method. Right now, I am going to be showing you how we would diagram individual premises. Now, folks, there are 4 kinds of legal premise statements that we can make in categorical logic. A, E, I, and O statements. They're in your textbook, and we also went over those. An A statement might be, all wombats are marsupials. Now, what I can draw right here to represent it are 2 interlocking circles. This first circle, we'll say, symbolizes the class of all wombats. This one is the class of all things marsupial. So what I'm labeling sector 1 is wombats but not marsupials. What I'm labeling 3 is marsupials but not wombats. And 2, which in a math class you would have called the intersection of M and W. This is the sector that represents things that are both wombats and marsupials. Now, here is how we diagram all wombats are marsupials. I'm going to shade in the entire area of wombats that is not part of the class of things marsupial. Now, I'm not shading the area where there are members. I am shading the area where there are no members. This is something that people frequently get wrong even after they've heard it, because it is counterintuitive for some people to do it this way. We are not shading the area where there are members. We are shading the area where there are not any members. So think of this as shading this away. What I'm saying with this diagram is that every single wombat that exists is part of the class of all things marsupial. Or to talk mathematics with you, it's because wombats are a subset of the larger set of things called marsupials. So we shade the area where there are no members. Now let's look at another one. E statements. No, what might we have here? No politicians are honest. Well, folks, that's not a true claim, no matter how you might think it. However, it's irrelevant whether it's true or it's false. It's still a statement that we could make and represent. Two circles. This first circle represents the class of politicians. The second circle represents honest individuals. Now, this middle section represents those who are politicians and also honest individuals. Now, this statement just says no politicians are honest individuals. Now, using the same convention that we use with A statements, we are going to shade the area where there are no members. That is what no politicians or honest would look like. Because what we're saying here is that politicians are all excluded from the class of honest people. And guess what honest people are excluded from? Yeah, the class of all politicians. Now, folks, suppose I flip this thing around and I said no honest persons are politicians. Can you guess what the diagram would look like? Exactly the same. Now, this is something that's not discussed in our textbook, and I'm not going to hold you to it. But that operation I did is something called conversion. It's when you flip-flop the subject and the predicate. Converting an E statement preserves truth because they are logically equivalent to one another. And that's why they have the exact same diagram. It would not work if we converted an A statement. Guess where we're going next? Next, we're going to look at an I statement. Remember, I statements are something like, some grasshoppers are green things. By the way, some are not, by the way. Some are brown and some other colors. Now, folks, unlike E and A statements, I statements are called particular affirmatives. We are actually affirming that there's at least one member of this class that's a part of this class. So instead of shading areas where there are no members, we are going to place an X in the area where members have been asserted. Or I should say one or more members have been asserted. So if this circle represents grasshoppers, and this circle represents things that are green, I would be placing an X in sector 2. Now, folks, what kind of other statement is an I statement structurally similar to? E statements. Because remember, for E statements, we shaded in the middle. For I statements, we put our X in the middle. Yeah, you would think that they would be more structurally similar with O statements because they say some. But logically speaking, I statements are more structurally similar to E statements. Now let's move ahead to do an O statement. Some Democrats are not pro-choice. Now, keep in mind, I am saying some Democrats are not pro-choice. So I'm going to place my X in the sum D that's not a part of what? That's not part of the pro-choice category. So I'm going to place my X in 1. Now, suppose that I flip this thing around and the sentence instead said, some pro-choice persons are not Democrats. Can you guess where my X would be? My X would then be in 3. O statements look more structurally similar to A statements. Now, folks, this is one of those tiny steps on the way to being able to do a Venn diagram test of a syllogism. So I'm going to start with an easy one that is not in any of my previous videos. I'm actually going to start out with the example that we just did a couple of minutes ago. Remember, that one was the one that said that was an AAA2. And I already showed you, using the counterexample method, that the AAA2 structure is invalid. I am going to demonstrate for you why it's invalid using the Venn diagram method. But right, if all cows are livestock, all pigs are livestock. Therefore, all pigs are cows. We already know this one was invalid because I explained it using the counterexample method. Let's pretend that we didn't know that. Now, when we perform the Venn diagram method, we're going to take what we had before, the 2 interlocking circles, and because it's an entire argument with 3 terms, there are now 3 interlocking circles. This first one represents cows, C, livestock, and this last one will be pigs. Now, folks, it is irrelevant which one you label which. It will still work out no matter how you do your labeling. You just have to make sure that you do everything else properly. I do it this way counterclockwise just for ease, mostly. Now, folks, this section 1 is C but not L or P. What I'm labeling 2 is C and L but not P. 3 is L but not C and not P. 4 is C and P but not L. 5 represents the area that's all of the 3 things. 6 is L and P but not C, and then finally, what I'm labeling 7 is P but not C and L. Folks, none of this labeling with numbers has to be done. I do this for ease of communication. I do this for ease of communication. Now, there are 7 distinct relationships that can be diagrammed here. What we're trying to figure out is if diagramming these two premises necessitates this conclusion or not. If it does, it's valid. Now, students who don't pay close attention, no offense to anyone, but if you don't pay close attention to this method, many students foul up part of it. Keep in mind that what you will be doing is diagramming each of the premises individually. You do not diagram the conclusion. It's because we are asking whether or not the premises necessitate the conclusion. So don't diagram the conclusion. Diagram the premises, and then you interpret the diagram to see if the conclusion has been demonstrated. Now, to diagram all C or L, remember what an A statement looked like? We had two circles here. We will shade 1 and 4. That is all C or L. Now, folks, you might have this question, so I'll ask it. Hey, you shaded in 4. That's part of P. Well, guess what? It's not just part of P. It's also part of C. Because we said all C or F, we shade away everything that's C that is not a member of L. So if it's convenient for you to pretend like that third circle isn't even there when you're doing these, do it. Whatever you need to do to help you to effectively do it properly works for me. Now I'm just going to check this off so I can check off that I've done it. Next, just to make things colorful and easy to see the distinction, I am going to diagram the second premise using a red pen. All P are L. I'm going to be shading in all of the area of P that is not a part of L. Now, folks, you may have noticed that I shaded 4 twice. Indeed, it is redundant to have shaded it twice because it was already shaded out of existence. I shaded it again simply to show you exactly how all P or L gets diagrammed. Now that I've diagrammed the premises, I can call the question. Has this diagram demonstrated that all P are C? The answer is no. It's invalid. If all P or C had been diagrammed, this would have also been shaded. So to demonstrate that you know how to interpret a diagram, I write, this is invalid. All P or C has not been diagrammed. And I'm going to further explain it would require 6 to also be shaded. So if all P or C could be validly deduced, this and this would have been shaded. It's not. Ergo, it has not been demonstrated. This is an invalid categorical syllogism. And by the way, if you demonstrate once that an AA2 syllogism is invalid, you know that AA2 syllogisms are invalid universally. Now keep in mind, this does not mean that other AAA mood syllogisms are invalid, because the middle term will be in a different place. So the relationships will be different. Indeed, don't make the bad inference, oh, an AA2 syllogism is invalid. So would an AAA3 or an AAA1 be invalid? The answer is no. As a matter of fact, AAA1s are valid. That one you saw in the textbook with the Greeks, mortals, and all that stuff, that was an AAA1, and that one was valid. And I can show you next time how we would diagram that one as well as a handful of others. Thanks.